In this video, we are going to cover section 4.3 notes. So first thing we're going to look at is classifications of polynomials. And so if you look at each of these polynomials, they're all written in descending order. So the x with the highest power, highest exponent, is listed first, then the next one, then the next one, then the next one. So with this top one, we would classify it as a quadratic. Highest degree is 2. It has 3 terms, so we'd call it a trinomial. The next one is a cubic because the highest power is a 3. It has 4 terms. Next one is a quartic. 4th degree is the highest. Next one is a quintic. Notice this one has 3 terms, so we'd call it a trinomial, but highest power is 5, so we call it a quintic function. Last one is a 9th degree. There's no special name for that. So the degree of a polynomial is the highest power in the polynomial. And so we're going to look at some graphs on why the degree is important and why we care about it. The leading coefficient then is the coefficient of the term with the highest degree. So for each of these, this leading coefficient is a 4, leading coefficient is a 2, that one's a 1, -6, and 5. And that number also tells us some stuff as far as what the graph's end behavior would look like. So with all of these examples here, you can see that when you read the graph left to right, they all end going up or increasing. That's the end behavior. And so what that tells us is that the leading coefficient was positive since they all ended increasing. So some examples for these, this equation of this quadratic could have been x squared minus 8x plus 13. Leading coefficient is a 1, ends going up. With this next one, cubic, could have been 0.8x cubed minus 2x squared minus 4x plus 3. Last one is a quartic. We know that it's a quartic just by that shape, that W shape to it. We have x to the 4th minus 6x squared minus x plus 3. So all of these leading coefficients are positive, which means it ends going up. If you look at the degree, this one is a degree of 2, this one is a degree of 4, and their starting and ending directions are the same. This one is an odd degree, so its starting and ending directions are different. So with all of these, you can see that our end behavior is going down, and so it is decreasing. So that means that our leading coefficient is negative. So an example, this is a quadratic. We know that by its shape, looks like a parabola. Now the leading coefficient would be a negative. So a negative 3x squared. With this one, negative 4x cubed plus 4x minus 5. Last one, negative 5x to the 4th minus 3x cubed plus 6x squared plus 3. Okay, so now we know by looking at the degree of the polynomial, if it is an odd degree, we would expect the end behavior to either start by going up and end going down, or vice versa, start down and end up. If it's an even degree polynomial, our end behavior would be going the same exact direction. Oops, that one probably shouldn't point towards it. I'm just going to redo that one, something like that. Now, if our leading coefficient is positive, they end going up. If our leading coefficient is negative, they would end going down. So the next thing that we need to be able to analyze are the types of zeros. And the term zero is kind of confusing because it's the same thing as x-intercepts. Sometimes you might hear them called solutions. And there's lots of other names that we use to classify basically where it touches the x-axis. Now, looking at this right here, when it's in factored form, that's how we can see our x-intercepts best. So, when you think about the term zero, we're looking for x values that would make our y value 0. So if you're looking in this first factor, x minus 2, if we were to plug in a 2, it'd make this turn into 0, so the entire product would be 0. That tells us that x-intercept, and we classify that as a single 0, and it crosses right through. Crosses right through the x-axis. It's a single 0 because I only have one of those factors. Now when you look at the next factor, we wrote it simpler as x minus 3 squared. That could have technically be written as x minus 3 times x minus 3. And so we classify that as a double 0. And so what happens is it ends up bouncing off the x-axis there. We also might call that a double root. That's the other word that you could hear us refer to as x-intercept as. So that bounces off. Another type of x-intercepts that you'll see is a triple 0. And I'm sure you can guess that's because we have this factor 3 times. And so at 1, since if we plug in 1, it'll turn into a 0, that's our triple 0. And so right there looks different. It does cross through, but it doesn't just cross straight through. It kind of sits there for a second. So we could say that it maybe hits the axis, stays for a quick second, and then continues. Okay, so don't forget that in addition to single roots, double roots, and triple roots, we also have imaginary solutions. And so that would just mean that it's not going to cross the x-axis. The other thing I want to make note of is if you look at the degree of this polynomial, notice that our end behavior is the same. So we would expect this to be an even degree. If you see a triple root here, that means that there were 3 x-intercepts, another 1, so that makes 4, and then a double, so that makes 6. The number of roots that you have should match the degree of your polynomial. So I would know that that's a 6th degree because it had 6 zeros. So even if you have imaginary, your imaginary solutions and your real solutions should always add to your degree. So looking at this one here, I'm just going to kind of count the little different directions. So this would be 1, 2, 3, 4. This would be a 4th degree polynomial, so I know that it should have 4 zeros. This one is a 1, 2, 3. That one is a 3rd degree. This one looks kind of different. So here's 1, 2, but notice that extra kind of curve right there. There must be something kind of happening in here. It just doesn't come back up quite as much. Notice that it is an odd degree though. So it doesn't quite look like a cubic. So my guess is that it's a 5th degree polynomial. Again, I know it's odd because it's starting and ending in different directions, and just something right there looks like there's some extra intercepts going on. So this one I can see crosses at 5 and negative 10, but then right here it didn't touch, and I know it should have 4 zeros, but I only see 2 x-intercepts. So that would mean that my solutions for D matches graph A. 5, negative 10, but again it's a 4th degree, so it needs 4 zeros. That means that these 2 imaginary must be what's happening here on the graph. Here's our third one. I know I should have 3 solutions. I have a single root at negative 10, and a double root at 2. That would mean that my solutions in B match graph B. 2, 2, and negative 10. 3 solutions, third degree. My last one, I can see it's crossing at negative 10 and 2, and it does kind of look like it bounces off 2, so I would suspect that that's a double root. So that makes 1, 2, 3 zeros, 2, 2, negative 10. But again, there's some kind of weird curve happening here, and the reason for that weird curve is probably because they're imaginary solutions. So I still have 5 zeros, however, these two aren't seen as x-intercepts. That means these were not used. All right, so I'm going to have a stop right before dividing polynomials. So that is going to be it for our 4.3 notes.